This video will help you with your Module 2 Assignment 2.05 Fundamental Theorem of Algebra. So the first question asks us to write a linear factorization of the function. So anytime we factor, the first thing we're going to look for is the GCF, which stands for greatest common factor. So here I notice my GCF is x to the 6th. And when I take that out, I'm left with x to the 2nd plus 81. Now here, we always want to check and see if what's left over, particularly here in this case, can be factored further. Well, you were trained in Algebra 1 and 2 that when you had x squared minus 81, that's a difference of squares. And when you factor x squared minus 81, you get x minus 9, and then again, x plus 9. But we don't have that here. However, what you have learned is you can use your complex numbers. So a sum of squares would be x plus 9i and also x minus 9i. So same process, very familiar as with the difference of squares we did up here, but because it is sum of squares, I like to list the first one as a plus because it keeps my same sign, but it doesn't matter which order. But we got to add that i component. So we got x plus 9i, x minus 9i, and then of course we have our GCF of x to the 6th, which should always stay there at the very end because that's part of our final answer. So that would be my final factored answer, x to the 6th times x plus 9i times x minus 9i. And I have then factored. Then the next question says, state how many imaginary and real zeros that the function has. So the first thing I'm going to do is I'm going to factor it and see if I can figure this out. So here I have 4 terms, so I'm going to factor by grouping. My GCF of my first group is going to be x squared, and that leaves me with x minus 1 in parentheses. Then my GCF on this side is negative 10. Remember that when you factor out the first number here, if the first number is negative, you will always take your GCF out as a negative. I'm going to take out a negative 10, and that will leave me x minus 1. So here I have x squared minus 10. Those are my outside numbers. And then I've got my x minus 1, my inside matching parentheses. You want them to match to know it's factorable. But I'm looking for how many imaginary and real zeros. Keyword here being zeros. So I'm going to take the first one, and I get x squared minus 10. I'm going to set it equal to 0. I'm going to solve by adding 10 to both sides. And then we get x squared is equal to positive 10. And the last step is to square root both sides so we can get that x by itself. And we get x is equal to plus or minus square root of 10. Remember that we want to put plus or minus when we square because we've got the positive version of the answer and then also the negative version. So let's take a look at what happens on the second example. Again, I have 4 terms, so I'm going to group them again. Very similar to the previous question, but there is a difference. When I factor this one out, take out the GCF, I'm still going to have an x squared, leaving me with x minus 1. Over here, I'm going to factor out a positive 10, because 10 is my GCF, and the first number is positive, so it comes out as a positive, leaving me again with x minus 1. So in this case, my factored answer is x squared plus 10 and x minus 1. So again, my objective is to solve for the zeros, so I'm going to set it equal to 0. X squared plus 10 equals 0. I'm going to minus 10 on both sides. And I get x squared is equal to negative 10. Again, I'm going to square root both sides. And I end up with x is equal to plus or minus the square root of negative 10. And we already know the x minus 1 because we just did that over here on this side, and we know that x is, actually we didn't do it, so let's go ahead and do that. Let's set it equal to 0. Sorry about that, I forgot that one. I'm going to add 1 to both sides, and you get x is equal to 1. This is the same exact thing over here, so we know x is equal to 1. So what you're being asked, though, in this particular question is to show how many imaginary and how many real zeros. Well, the square root or radical 10, that's a real number. So here I've got 2 reals, and then x equals 1, that's 1 real. So together, this particular function has 3 reals and 0 imaginary. Now, it's different on the other side, because again, x equals 1, we know that's a real. It's 1 real there. Here, you may have noticed that I put a negative under the radical, and hopefully you've learned that rule that you can't have a negative under the radical, or it's not appropriate. So that means we can use an imaginary number to express it. So that would be plus or minus that, so there would be 2 imaginary numbers. So together, you would just have 1 real and 2 imaginary. And then you've answered that type of question. This one says, write a polynomial function of minimum degree and with real coefficients whose zeros include those listed. So I'm going to start with these first two because we did these in the previous video, so hopefully you remember. If your 0 is positive 8, which is what this is right here, that means my factored form should have been x minus 8, because when I set it equal to 0, I'd be adding 8 to both sides. So again, if I have negative 16, that means my factored answer was originally x plus 16. So those are the real sides. So before we get dealing with the complex part here, let's go ahead and multiply this one out. So x times x is x squared. X times positive 16 is positive 16x. So all I'm doing here at this point, just so everybody's clear, is I'm looking to go ahead and make sure I distribute each piece so I get a single answer. So I get negative 8 times x is minus 8x. And then lastly, negative 8 times positive 16 is going to be negative 128. I got some like terms right here in the middle. Ended up with x squared plus 8x minus 128 is what that comes out to be. So now let me switch colors here. We're going to deal with the 4 plus 10i. When you're dealing with these, what's going to happen is you've got this one, and then you've also got the conjugate, which remember is the same thing with the opposite sign. So instead of 4 plus 10i, 4 minus 10i. And when you're looking at these are both positive overall. So what we're going to do is we're going to have x minus for both of them. So you've really got x minus 4 plus 10i. And then x minus 4 minus 10i. But be careful, because remember this essentially is minus to everything inside here. So if you're going to distribute it all the way out, make sure you have x minus 4 minus 10i. Same thing here, x minus 4 plus 10i. But if you forget to do that, it's not the end of the world with this particular type of question, because notice these two are the same. They pretty much just reverse places, so it's okay either way. So what we're going to do is we're going to distribute out the same thing we did on this side, but we're just going to do it over here. X times x is x squared. X times negative 4 is negative 4x. X times 10i is positive 10xi. And over here in the middle, negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16. And negative 4 times positive 10i is negative 40i. Then lastly, we're going to do this last term. Negative 10i times x is negative 10xi. And then negative 10i times negative 4 is negative 40, I'm sorry, positive 40i. And then negative 10i times positive 10i is negative 100i squared. So now we're going to clean it up. The x squared, there are no other terms like it, so I'm going to list that here as x squared. Negative 4x, be a like term with negative 4x. No other one, so it's negative 8x when you combine it. Positive 10xi, negative 10xi, those are going to cancel each other out, and there are no other ones with xi on them. And then we've got the negative 40i and the positive 40i, so they cancel each other out. Then you got the plus 16. And then negative 100i squared. Remember, I squared really is nothing more than negative 1, so it becomes plus 100. I'm going to add these two together to get x squared minus 8x plus 100. Okay? So the last thing that you're going to do for this particular question, I'm running out of space to do it, but I'll show you how to do it, is you're going to take this first one here, x squared plus 8x minus 128, and you're going to multiply it by this one that you just did, x squared minus 8x plus 100. So I'm out of space to work it all the way out, but it's just no more distributing each one of these, same way we did with both these problems. Combine your like terms and poof, you've got your equation. Last but not least, using the given 0, find one other 0 of f of x. So the 0 that they gave me in this case is 4 minus 47i. Please don't overthink this question, because according to the textbook and the lesson that you read, it talked about conjugate pairs. So if one 0 is 4 minus 47i, then its conjugate must also be a 0. Remember, conjugate is the same thing with the opposite sign. So if 4 minus 47i is a 0, then 4 plus 47i must also be a 0 because they are conjugate pairs. Hopefully this helps you with your lesson, and good luck.